All right, good morning, everyone. Welcome to Intro to R, brought to you by the UCLA Collaboratory and the Institute of Quantitative and Computational Biology. So today I'll kind of briefly go over kind of what the capabilities of R are, and then we can go into like the general outline for the course and getting set up and getting started. So right now I have RStudio Desktop opened up on my machine, and I have so nobody needs to load anything in this moment. But at the end of the session in day 3, we're gonna learn how to use something called R markdown, which is kind of a useful tool to generate reports that have R code built in. And so you can see as I just lazily scroll through here, there's it looks, you can see a variety of things typed into here. And the long-term goal is to be able to take this document and create a report that you can give to someone or submit in some form. This is the report that will get made at the end of it. This is part 2. This is not something that I've shared with y'all yet. But in summary, what we're going to be learning today is we're going to be learning about R in general, some of the background, getting familiar with the interfaces in order to work with this software. We're going to learn how to R is a very useful statistical programming language. More on that soon. We're going to learn how to import data into R and modulate and work with the data in a variety of ways. We're going to wrangle with the data, so like manipulate it, transform it, create new columns, do different things with the data, clean it up so that we can visualize it in ways that are really, really useful. We're going to be working with some COVID data pulled from the New York Times, some public databases, and we're going to learn how to visualize trends. So in this case, we're going to create a plot with COVID cases in large states and look at the overall cases per million in different states. We will then move on to figuring out how to facet this. We're going to split up plots and make them in a very rapid manner. We can also look at how data is distributed. We're going to learn how to create violin plots and adding mean and standard deviation values to plots. And then we're going to do some very, very basic statistics on some data that we're going to compare. So we're going to learn how to do a 2-sample t-test on some of the data that we're working with. So that's like the 1,000-foot overview. As I had mentioned, this is a long-term goal that we're going to be creating this HTML this report. It is made in HTML and it is made with a table of contents that can kind of easily, quickly move you through the different sections. I will be going back to this to give kind of summarizing like what we did in the session, but we're not going to worry about working with this report until day 3. So that's just kind of to give everyone a taste of where we will go. The next thing that I want to do is I want to get us started working with RStudio Cloud. So if folks have logged into the box folder, let me pull up the chat window just to be sure I can see it. To answer Patrick's question, there are no PowerPoint slides for this workshop. All of the materials, you're going to get them though. They're going to be deposited in the box folder, and the recordings are going to be available for folks in the future. So if you can see the course materials, then that is kind of the first step. For those of you who have created a session in R, this is what it looks like when you first log into RStudio Cloud. I'm just going to log in with one of my accounts that doesn't have anything really installed in there. It should look very similar to what yours looks like. So give me just a second, loading. So you'll probably have nothing in this projects folder. Basically, the best way to get started with the materials is to click on this new project button. It's gonna give you this fancy deploying project text. Sometimes it takes a little bit of time for it to get started and set up. We'll give it a moment. While it's deploying the project, you can go back to the box folder. And what I would do is I would recommend just downloading all the contents in course materials. Oops, oh, I need to log back in, my bad. I recommend downloading the course materials folder to your desktop. That will allow you to open it either in RStudio desktop or in RStudio Cloud. So the way that I would do this is I would just click the ellipsis and click download. And it's going to download as a zip archive. I'm going to move it to my desktop. And then I'm just going to save it there. I'm saving just this folder part 1 for now. So show in Finder. So in my desktop, I have a bunch of stuff in here, but you can see this part1.zip that has downloaded. The next thing that you want to do is you're going to want to open up that zip file. So it'll create like a folder with part 1, and you'll have all of the materials for to work for the course today. If you are using RStudio Desktop, all you need to do is double click or open this part1.r project file. We're going to talk more about our project files in a little bit, but all you need to do is double click on that. It should automatically open up RStudio on your desktop, and it'll take you to the correct folder where everything is going to be working in. If you have loaded into RStudio Cloud, which should be the majority of the class, you should see by now this type of workspace opened up for loading. So since this is kind of on the cloud, it's not accessing your desktop directly. So you're going to have to upload the course materials themselves into RStudio Cloud. In order to do that, there's this window in the bottom right-hand corner. What you want to do is you want to look for this upload button, which I'm like circling with my mouse here. If you click on the upload button, it'll take you to this kind of interface here. What you can do is choose a file to upload. And you want to go to your desktop. You want to go to the part1 file, and within the part1 folder, there is a part1.zip file. All you need to do is click open, and then it'll load in the part1.zip file, and then hit OK. It might take a little bit of time to upload it because it's a relatively large file. Well, it's not huge, so it shouldn't take a ton of time. But you upload the file, and it should show a new environment here in the bottom right-hand corner. We'll give it a second to upload the file. And of course, if you have questions or if you're having trouble, please feel free to make a notification, show up an expression. Okay, so the part1 materials have been loaded into RStudio Cloud. This is a pretty good place to start. The materials that we're going to be working with in terms of instruction are going to be in this part1.r file. This is called an R source file. We'll talk about that in a little bit, but if you click on it, it should open in the top left-hand corner, and you should be able to see, welcome to the UCLA Collaboratory Intro to R course. If you're working in RStudio Cloud and have gotten that far, please throw up a thumbs up, throw up an expression, anything to let me know that you're following along, things are working. For the folks who are so I see so I see some people don't have the zip file in order to get the zip file, so there is going to be a zip file within within the part 1 folder. So if you have downloaded the part 1 folder from course materials, which we did by using the ellipsis and then download button, you should see the zip file in your in the folder on your desktop. So someone asked, what if we don't have an upload button? So I think, so if you're working in RStudio desktop, so this is what I was going to go to next. So this is, let me clean up my RStudio desktop a little bit. So if you, so I'm going to just actually close this, don't save. So I'm going to go to the folder in my desktop. Oops, that's my email, not my Finder. One second. Why can't I see my desktop folder? Oh, there it is. Desktop. So if I go into the part 1 folder in my desktop, in order to get it open in RStudio desktop, you could just double click on this part1.r project file. That's going to open RStudio. And we should see something like this. In the case that you're using RStudio desktop, you'll notice that you do not have an upload button. And you should see a similar environment that we have here. We should see the part 1 files. We could see all the files that we're working in here. So for the person who is having trouble seeing the upload, the upload button, does that make sense? If you're working in RStudio Cloud, there should be an upload button.
Abraham?
Yes.
So I got RStudio up and running, and I'm having trouble with RStudio Cloud.
Okay.
I don't want you to have to duplicate stuff. Should I just because I'm obviously going to fall way behind really fast. Or is there like a possibility of just uploading the data and working? Because I've used RStudio desktop before. So is it possible for you to just say how to get this data in here, and then I can use the RStudio? Otherwise, I'll just watch.
No, that's okay. Are you able to access the materials in the box folder?
Yeah, I have the data.
Okay.
It's in my download directory.
Are you talking about like all of the materials, or which data are you referring to?
Whatever you're working with right now.
Okay.
I don't want to take up too much time though.
No, it's okay. We have a lot of time at the beginning to get set up. So and you might be having.
If it's better for me to try to catch up on RStudio Cloud, I can do that too.
Okay. Yeah, it could be better to or easier to catch up on RStudio Cloud, because everything should load pretty smoothly into RStudio Cloud.
Okay, I'll just do that. I find myself doing these classes that I can't chew gum and tap my head at the same time anyway. So
it's all good, no worries. We do, like I said, we do have a lot of time at the beginning to get set up.
Okay, I'll get that going. Thanks.
Cool. So I see other people are seeing this as well. Packages are required, such as dplyr, ggplots2, and some others. We're going to get to installing packages in just 1 minute. So we shouldn't have to download any Git file or Git repository. As I'd mentioned, all of the stuff should be in the box folder. So people don't have access to the box file. I'd love to see if there's anyone else who can't access the box file. We did know that there was a limit in terms of the number of people who would have access to the box file. I just want to make sure that it's not affecting a lot of people. I'm gonna share the link. Share this folder. Yes, I will repeat what we should do to open up RStudio on desktop again. So just really quickly, I'm going to copy the link to the box folder, and I'm going to drop it into the chat. Okay, so in order to open up RStudio on the desktop, if you have downloaded the materials from the box folder onto your desktop, you should you can get into the part 1 folder, and then there should be a file called part1.rproj, R-P-R-O-J. If you just double click on that, it should automatically open up RStudio, and it'll take you into an environment that looks like this. So it's going to be this part1.r project. Jinfen, were you able to access the box link that I sent into the chat? Well, just let us know if you are able to access the box file. All right, so
if we're having a little bit of trouble with RStudio, do you have some time after on desktop? Do you have some time after the workshop to fix it?
Yes, I will be hanging around for a little bit after the workshop for anyone who's having trouble getting set up and with any additional questions. So yeah, I'll be hanging around after the workshop. Plus, I do host office hours throughout just like regularly. So if people have follow-up questions, they can feel free to set up an appointment with me. So I see that.
Sorry, I should use the Q&A.
That's okay. I see that Jinfen still doesn't have access to the box file. Lee or Jamie, do you think it's possible for you to create like a separate like Google Drive folder that we can use temporarily to that's like open for people to like get access to for the file? I know that the box prevents people from accessing because it requires UCLA login.
Are the people who can't get in, they do have UCLA logins, right?
So this class isn't closed to people outside of UCLA. So there are people who do not have UCLA logins.
Can I email, if there's not that many, can I email the file? I'm not sure how to make a box file that everybody can get. Lee, I don't know if we can make something everyone can get into.
So Ibrahim, you mean like duplicate it in Google Drive? Yeah,
duplicate it in Google Drive and then just share it as an open link, if that's all right.
Oh, okay, I see what you mean.
Yeah.
Yeah.
Could you do that, Jamie? I'm actually, it's still downloading for me, so it might
That's okay, I think I've got it. So I'm gonna put, it comes down as part1 zip?
Yeah, it should come down as part1 zip.
Okay, I'll put that in there and put the link up. Be in there in a minute.
All right.
Thanks, Jamie.
Sure.
Awesome. In terms of attendance recorded for 275, I think that is something that Eloy is working on. For the folks in 275 and I think it's 199, those two courses, there is going to be an assignment that's gonna at the end of day 3 that's gonna determine your grade and like attendance and everything. And so so just focus on, we can focus on that, and then for other questions regarding attendance for the course, you can direct them to Eloy for now. Okay, so let's get started. Yeah, let's just get started. So for those of you who So let's just really quickly actually go, I'm gonna go to our Studio Cloud for a moment. So one of the kind of default settings for R is that you'll see that certain lines of code will like go off screen. So I'm scrolling to the right here. And we don't really wanna do that. We want the text to wrap. So the best way to do that is to go under the Tools option and click on Global Options. Once you're in Global Options, you can go into the Code tab and then click Soft Wrap R source files. This setting will help it so that the text wraps instead of like goes off screen, which is going to be helpful for just reading the code in general. So if we just hit OK, we should see that. So I'm trying to scroll to the right now. I can no longer scroll to the right. That's you might not be able to kind of see that in like the kind of immediate here, but wrapping source files is going to be really, really useful. If you didn't have access to the file inbox, Jamie just dropped a link into the chat to be able to access it in Google Drive. So just to give a quick overview of R is one of the most commonly used and powerful statistical programming languages, and is used to analyze and manipulate data for virtually every professional industry. From people use R from artists to people in business, to people in finance, to people in biomedical sciences, to people in social sciences, humanities. It is a really, really robust and very useful tool. To the point where, like, you know, I used to use Excel a lot and did almost all my visualizations using Excel. I've almost completely moved all of my work to R just because, you know, once you become comfortable with it, it's so much more robust and can do so many, and is like so good at customizing both data visualization, but just working with selecting with subsetting, filtering data. It's just a really, really robust tool. And so that's one of the reasons why I like it a lot, and one of the reasons why I like to teach it. So in terms of how R works, we'll see a lot of examples of this over the course of the sessions in the next 3 days. But the way that it works is R reads your data. It's usually going to be from an Excel file or a text file, like a CSV or tab separated file. And it's going to make an image of it, like a structure of it. And it's going to store that in temporary memory. When you edit the data, you're only editing like a kind of an image or like a subset of it. But the original data is unaffected. So you can create and alter the data sets within R. You can write them back to a permanent file. So this is called non-destructive editing. And so that allows you to heavily manipulate data without modifying the original file. So you can imagine if you're working with a file in Excel, in order to filter, subset, do different things, you have to do all of that within your Excel sheet. Whereas R, you could just create an infinite number of these images or these objects that you can manipulate and then create different types of visualizations with without destroying the original CSV file. So R can do almost anything that you can think of doing with your data. So it really kind of expands the amount of creativity you can apply on analyses. And hopefully we'll get a chance of seeing some examples of that. By using script files like R files, like this one, you can keep a record of everything you've done to manipulate and analyze your data. So that'll be useful for you later, because then you can save all of the code that you did and any of the notes that you write within your code to encourage the reproducibility of your own work, which is really important. If you're doing research, you want to make sure that not only you are able to reproduce the work, but also anyone who is taking the data that you publish or the work that you publish, and they can reproduce your work as well. So as I had mentioned before, this course is designed for learners who have little to no experience with R programming. So as I had said, and as people might have noticed, we're going to take our time going through the early stages of this. I will be sticking around at the end of the workshop in case anyone has additional questions or is getting hung up on different things. So just trying to point out, or all I'm trying to really say is that like this is really for people who are new to it and want to learn. And if for those who are like in the more intermediate or advanced stages, I know that there were a few people who had registered for the course who are a little bit more advanced. We're going to get to some more advanced techniques, but only at the end of this session. So I hope that's all right. As for our course outline, today I'm going to kind of introduce RStudio, how to find help, and introduce some of the cheat sheets for RStudio, which actually made it a lot more possible for me to start learning R. We're going to go over installing packages, which people are probably noticed the warning on my thing. If you don't see this warning on your screen, we're going to learn how to load libraries, learn a little bit about data structures and classes, and we're going to learn to import data. That's what we're going to go over today. We're going to then, in day 2, we're going to do some data transformation, data wrangling, examining our data sets. I need to upload day 2 or update day 2. There's some changes that I made. And we're going to go into some data visualization with ggplot. And in day 3, we're going to do more data visualization with ggplot, and we're going to learn a little bit of R markdown. To take notes in your R source file, if you want to make your own edits, if you put the pound symbol, that will, it's the best way to leave a note. Because if you don't leave the pound, put a pound symbol, R might try to read it as code in this document. So you'll see that if I don't have that hashtag, you'll see this little X appears here. That means that it won't be able to run that code. So that shows us that this we know that this shouldn't be read as code, so we can put a little pound symbol or a hashtag, and that'll make it so that R doesn't try to read it as code. Does anyone have questions before I go into the layout, soft wrapping code, and saving files? Are
I
people?
put this on the Q&A doc, but I feel like it's a good question to say out loud. Is that okay?
Sure. Sure.
How do we have good writing script or good notes as like a technical skill?
So as you kind of get more and more familiar with R, you're going to learn the syntax of like writing it properly. I'm going to do my best to communicate like best practices for like writing the code itself once we actually start getting to the code. For me, I try to extensively annotate my notes so that I know what every step does. As I've been coding in R, I end up using a lot of packages and libraries. We're going to get to that into like these different packages and libraries that you can use for the code. I use things that there's tons of documentation. If I look at the code that I wrote 3 months ago, I might have forgotten what it actually exactly does. And so writing notes helps me remember like, oh, this is what it does. This is something to look out for when I'm kind of revisiting the code later. It's a good practice for reproducibility as well. Thank you for that question. That was a good question.
So I caught up with RStudio cloud. Can you just show the upload, and then I think I'm caught up.
Sure. Yeah. So just no, it's all good. It's all good. Just to kind of refresh on the upload, there's a little button in the bottom right-hand corner. So I'm going to talk about what all these windows are in just a second, but there's an upload button right here. You should, so once you upload this, you can see choose file. And then I would go into the part 1 folder that you had downloaded to your desktop. There's this part1.zip in this folder. If you just open this file, so I'm gonna, and then hit OK, it should take you to the space that we're in right now. I'm gonna hit cancel because I don't need this. I had already uploaded it, but this should work for you.
Great, that's fine. I'm good, sorry.
Okay, all good, all good. Any other questions? All right. All right, so let's just briefly go over the layout of RStudio. In RStudio's kind of default setting, the left side is going to be the terminal. So we can see that we have console, terminal, and jobs. So I haven't. The only relevant tab for you right now is going to be this console, and you can see that it'll tell you once it opens. So I'll just make this a little bit bigger. What version of R you were working with. They often have very hilarious names like Bunny Bunnies Freak Out. And you can see some additional information about the version of R that you were working with. As I'd mentioned, R is an open source software, which means it does go through a lot of iterations and changes over time, but that means it'll be freely available and accessible to anyone who wants to use it in perpetuity. So, like for example, you have to pay for Microsoft Excel in order to use it, whereas R will be free and remain free. Once you open up files like the part1 file, as I mentioned, this is an R source file. This is a place where you can write R code and write your notes into. All of this is going to be showing up on the left-hand side. And we're going to go over in just a second how you run code from an R source file.
I wanted to tell you that you're doing stunning. I'm so happy.
If you for everyone, can you please be muted when you're not speaking? That would be really helpful. In the top right-hand corner is something called the global environment. As we start creating and uploading data sets and creating objects within R, this is going to get populated in here, and we'll see what that looks like as we start uploading files. People are already seeing this since we've been working with this, but in the bottom right-hand corner, there's a number of useful tabs here. The files just tells you what folder you are working in, or the working directory that you were working in. We're going to talk a little bit more about that soon. There's a plots tab, so whenever you create plots, they should show up on this tab. There's a packages tab, which will show you all of the different packages that are installed in your R interface. And then there's the help tab, which is going to be really useful to kind of learn about different like the syntax for different code that you're working with. And the viewer tab, which I actually don't know what the viewer tab does. I don't know if Lee or Jamie know, but yeah.
Oh, sorry, did you say which one? Viewer tab?
The viewer tab, yeah.
Oh,
have you ever used that before? I've been working in R for a long time, and I've never used the viewer tab.
I think I might be mixing it up with, there's another button or tab that lets you view the data, but maybe that's it, because maybe if you view a spreadsheet, it might show up in there. But usually it'll show up in your console or in the R.
Right.
Like in the left-hand side. So
right.
I haven't used that.
What about the R presentation files?
I
think they show up in the viewer. Be. I haven't done an R presentation for a long time, but I think they may show up there. Sorry,
yeah, so no, it's all good. Patrick says that in the text, it says the viewer tab is for viewing local web content or web-based graphics, which is what I read as well. And like, I've been trying to, like, whenever I like use local web content or web-based graphics, I just do it in my browser. So, but anyway, I don't want to get us distracted, but yes, yeah, the viewer tab, as described by RStudio, is for viewing local web content or web-based graphics. But for the purposes of this workshop, we probably won't be using this viewer tab for now. So there's definitely a lot to explore in RSpace. There, if you want to adjust your windows, there are these like lines that go across here, and you can move them up and down to change the shape of things. This will be useful as you create plots, or if you want to view view things a little bit differently. I'm actually going to maximize my window here. Make this a little bit bigger. Okay, so so the last thing that I want to talk about before we go into the cheat sheets is creating new R projects, R source files, and R markdown documents. We have been working with an R source file, this kind of file right here. In order to create a new R source file, there is this like square with a plus symbol in the top left-hand corner. If you click on this arrow down, it says R script, R notebook, R markdown. There's like a whole bunch of different types of scripts that you can create in RStudio. The basic form is this R script. And it'll create this like untitled one script here. And so this is a new R source file and can be saved as a new file in your folder if you want. So so I'm saving the file. I just use the shortcut Command S, and I can give it like example R source file. .r, and I can just save it, and you'll see that it shows up in my directory here. But we're going to go back to part one, the R, to create new R projects. So this isn't something that you can do in the interface in RStudio Cloud, but just really quickly, I'm going to go to my RStudio desktop to show people how they can do this. So, so my RStudio desktop, you might notice, looks different than the RStudio Cloud. I like customized the way that it looks. But to make RStudio our new R projects, there's this little cube with an R in it and a plus symbol. This will take you to create a new project, which you can do by creating a new folder. So a new directory, or you can save it within an existing directory. We're not going to have to create any projects for now, but creating our projects is really useful because what you can do is then you can open them like we did earlier, and it'll open up the environment that you are working in the correct folder in order to do all of the code there. So I'm going to go back to RStudio Cloud. So does anyone have questions about that for now before we go into installing and loading packages? Any questions about the interface or what buttons do? Oops. So we can create projects with cloud. It's all good. I was like, oh man, did I really be unclear? So the way that our projects are created in RStudio Cloud. So I'm going to just duck out of the cloud for just a moment before going on to installing and loading packages. So if I close the project, for example, so let's see, how do I actually close the project? So if I click on my workspace, you'll see that there are all these projects here. This is the way to create a project in RStudio Cloud. So it automatically creates the folder, the directories, the environment that you need. So it's a little bit different than working within your desktop in terms of the way that it looks. But functionally, creating a project in RStudio Cloud is the same as it would be in RStudio Desktop. So I'm just gonna actually, before I go back into the project, for everyone who's working in RStudio Cloud, I highly recommend at some point looking at the cheat sheets. This is going to be really useful as we start doing coding. There's a whole bunch of really useful packages that RStudio has created cheat sheets for, which like give you the syntax and like what the actual command is to do a variety of things. The ones that we are going to be working with most today are data transformation with dplyr is the package. So if you haven't done so, I recommend downloading that so you can look, downloading it later at the end of the session so that you can learn more about it later, and data visualization. Data visualization with ggplot2. These two, data transformation and data visualization, are going to be what we are going to be working with the most in terms of commands. There's a couple others that I recommend in the materials, which are useful, but these two are the most important. All right, so I'm going to go back to the project now. I clicked on my workspace to get to the main area, and Untitled project is the one that I created this morning. I should name it, so I'm going to call it Intro to R Collaboratory, just so that I can remember which one it is. I'm going to scroll down to installing and loading packages. All right, so if you're ready to talk about installing, or for me to talk about installing and loading packages, throw up a thumbs up, show a reaction. I'd love to kind of see how people are engaged, if they're following along. And if you're not following along, throw up another expression, and or feel free to hang around at the end of the session, and we can address any questions or issues that you have. Thanks everyone for throwing the thumbs up. That's super helpful for me. Super much appreciate it. Okay, so going into installing and loading packages. So for almost all programming languages, it will require loading or installing specific packages in order to execute particular functions. That is true for R. It's true for most programming languages that I can think of. So for everyone who noticed that these different packages are required but not installed, this is R's like very easy way of telling you that certain things need to be installed. But I want to get everyone to have a little bit of practice installing the packages by typing things out. So these are the packages that we're going to be working with over the course of the next 2 sessions. I highly recommend, wait, what was I going to recommend? Well, we'll just get into installing the packages for now. Oh, what I was going to say is I highly recommend installing and loading the packages before you start working with the data. That will make it easier so that you're not installing things in the middle of the session. So the way to install packages is by writing the code install.packages, and in parentheses, and in quotes, using writing it like this. So just to run this code, you can highlight it and then hit this run button. And it'll take time to load. So for those of you who have already installed—
Sorry to interrupt. How do I get back from your demonstration, your workspace, back to the intro R?
So in the project that you created, you should be able to, so from the workspace, so I'm gonna let this install. From the workspace, there should be either Untitled project or like the project that you created earlier. If you click on that, it'll take you back into this session.
Oh, okay, great. Thank you.
So someone mentioned not being able to create projects with cloud. If you're having some internal server errors with cloud, hopefully too many people aren't running into that issue. It may be useful to install RStudio Desktop and try to work with it on your desktop directly. Sometimes when like a lot of people are using RStudio Cloud at the same time, it'll run into issues. The only time I've ever experienced that though is actually in an RStudio conference when like they're asking 10,000 people to log into RStudio Cloud in like the same moment. But anyway, yeah, if you're not able to do that for now, I recommend trying to install R and RStudio desktop on your machine. And then if you want to hang around after the session is over to like get caught up, that's all right too. So continuing, so you'll see that as the package is installing, you'll see like a bunch of stuff happen. And basically that's just our thinking and installing its work. So I recommend to everyone to install, just go ahead and you can either like copy and paste this code because it's easier that way, and install dp. And just go ahead and install all the packages that are listed here. You should see while if the code is running, you should see this little stop symbol. It's like thinking and downloading everything necessary to install. So I'm going to give a few minutes for everyone to go ahead and install those packages. You can also type it out. You might, so if you run into errors, it could be that there are typos in your code. So for the question, can we just rewrite on the previous code? So I'll just show you an example table. So I can run this, and then I can, in fact, I can just replace this with and run this code. Once Tibble is installed. So you can rewrite on the previous code, but then you lose the record of having that code there in the first place, which especially for loading packages, like we're gonna like load packages using the library command. I don't necessarily recommend using like rewriting on the previous code for loading libraries, because you need to make sure that all of the things runs. So here is my example where I overwrote the code. Run. So for the warning message, the package is not available for this version of R. Make sure that you have the package spelled correctly. Typos are the most common error in R, so I highly recommend just double checking that everything is spelled as described. So if you don't want to push this run button and you want to just run the code, you can highlight the code that you would like to run. And if you're on a Mac, you hit command return, and the code should run. If you're on a PC, if you hit control return, the code should run. But make sure that you highlight the code, and it should run. So as I mentioned, this is going to take a little bit of time. ggplot2, and I'll install the last one. So if you want to spare yourself the hassle of just retyping, installing packages over and over again, you'll see that there's a warning: packages, so on and so forth, are required but not installed. The other thing that some folks have done is just click that install button, and it'll automatically install everything, which should be the easiest way to installing and getting set up. So we have a question: I installed all the code, but why do I see a red dot in front of one of the codes? So are you referring to like in front of the 113, or like in front of the line? Usually the red dot in front of the line means that there was some spelling error, or like some like syntax. Syntax is the way that the code is written. Some like error in the way that it's written. So you could double check the spelling of either the command itself, install.packages. You could check the spelling of the package itself, or you could just double check to make sure that there are quotes around your package in order to get it to run. So at this point, I have installed all of the packages for this session. Is that if so? So it's just about the hour. So what I'm gonna do is I'm gonna start us off on like a 5 to 10 minute break. I know we haven't like really gotten into things yet, but for anyone who's like still catching up or having issues with installing, you can stick around and we can troubleshoot that for now. But let's take a quick break, a bio break at 10:10. We will get back started, and we're going to start loading libraries and start importing some data.
Hi, Ali. I have a whole bunch of error messages in the bottom of the console. What does that mean?
Well, so in order to best take a look at what at the errors that it's helpful to see what the code is that you ran. So if you can type that into the Q&A sheet, that will be helpful. Just installing the packages, it will look like, you know, there's like all this stuff that's going. Are you actually the question? Oh yeah. So yeah, for everyone, we'll start our 10-minute break now. We'll get back started at 10:10. Yeah, let's see.
It says a lot of done above, right? But as you scroll to the very bottom, it has a couple of like R color rather, I think.
Mm-hmm.
And yeah, why? Because it's already installed, right?
Yeah, so let's see. Are you able to copy that that code into? I just pulled up the Q&A document. So actually, what I'm going to do for a little bit is I want to stop sharing my screen,
You want me to share?
No, it's okay. I'm gonna look at the questions for now and try to address them.
Okay. All right.
So
I don't know if it doesn't affect later to follow the class, it will be fine. I'm just worried I won't be able to upload.
Yeah. So let me just take a moment to look at the questions in the chat. A lot of things came in. So it is okay. I'm seeing a lot of questions. Okay, so for the people who are getting errors, are you working in our Studio Desktop or our Studio Cloud?
Wow.
Cloud, okay.
Should I re-upload, reinstall, or?
No, I think so. Sometimes when things are like loaded, there are like other dependencies. So like certain packages require on other packages to function properly. So those are called dependencies. So for the people who are getting dependency related questions like RCPP, this is something that someone was saying for Lubridate. Some people were saying this also for ggplot. That kind of like activity is normal. You should see like a bunch of like code run through. It'll say like, oh, like this issue is happening. I'm installing like these other dependencies. Yeah. So for the desktop issues, so I'm just taking a look at. So if there is like a little stop sign in the top right hand corner of your console, that means the code is running, and you won't see like a done indicator yet. I'm reading some of the questions. If your question hasn't been addressed, feel free to say something. I'm looking at the questions Q&A doc as well.
I downloaded everything. My console says my packages are downloaded, but 2 of the 6 of them, I'm still getting the message at the top that says the packages are not installed.
So can you try just retyping the install.packages with that code in there? Have you tried that already?
Yeah.
Okay. Is it, do you know if it's like running into particular issues?
I mean, at first I was getting a lot of like many different downloads and a bunch of stuff happening in my console. Then I redid it a 3rd time and it just says installing binary package Lubridate done. But then when I look up, it just says packages ggplot2 and Lubridate required but not installed.
Oh, I see. So if it says that it's required and not installed, but you already ran it, it needs to like kind of refresh its brain to know that it's been installed. So the question about, I think it should be fine if you've installed, if everything ran smoothly and it still says the packages needs to be installed, it's just that it needs to like refresh the brain for RStudio. Just give it some time and those errors should go away. Yes, the names of the packages are strange. So the way that I learn about new packages in R is I'll usually like Google search like what it is that I'm trying to do. People in like forums. So another thing that I don't know if I mentioned this already. Oh, we're gonna get to the finding help section in a second. There's a variety of forums where people discuss like how to do things in R, and in a variety of coding languages. I'll talk about what those are in a second, or in the next section. Usually when you like search for like how to do things, you'll find people discuss like different packages that they've installed. Another really useful way of figuring out what packages to use is by browsing through the RStudio cheat sheets. There's a lot of resources on like what packages and what commands do different things. Those 2 are like useful ways to learn like the different packages that can be used for different things. I completely agree. The packages have some very strange names and can be confusing. For folks who are copying in the errors into the Zoom chat, it's very difficult to read in this way. If you could copy it into the Q&A document, that would be super helpful. So I'm taking a look. So sometimes R will kind of spit out like download errors, or it'll like try to work on it'll like try different methods of downloading the packages. So there might be, it might say that there are errors when it executes correctly. The best way to check, so I'm gonna share my screen again. So it's 10:10. and I'll address some of the other questions that have come in. So the best way to check if the packages have been installed is you can go into the packages tab. So someone just asked this. You can go into the packages tab. And you can just either search for or check to see if the packages were installed. So there should be ggplot in there, lubridate should be in there, dplyr should be in there up here. All the ones that we had installed earlier, so here's a list of them, should be in here. You can also search for packages. So if we're looking for Tibble, if you just search for it, you can see that that's installed. So that's like the best way to just double check to make sure that the packages were installed. There are a number of ways to load packages. We're gonna do that right now. So there's a command. Sorry, I'm like scrolling around to make sure that I'm following the right space. Before we talk about loading packages, I'll just quickly talk about what packages we just loaded. The ones that we loaded, tidyr, dplyr, and Tibble packages, these are all built to organize and clean and manipulate data. So this is like selecting columns, filtering based on certain categories, merging tables, pivoting tables, all that stuff is done with these different packages. Tidyr being probably the most important of them, and dplyr being the second most important. But we're going to be using all of these packages today. Or over the course of the lesson. The packages ggplot2 and rColorBrewer, these are for data visualization. So ggplot is a very common tool that's used for creating plots of a lot of different kinds. When you look at the data visualization cheat sheet later on, you can see the different types of shapes and ways that ggplot works. And we'll talk about that quite extensively in day 2. rColorBrewer is like a color blending package that's really useful for assigning and customizing the colors of your plots. The lubridate package is one that makes it easier to work with dates and times. Yeah, so that's it's useful for working with dates and times. So that's going to be handy later on when we're plotting things with based on the date and time. Another good question that was asked. So if I install a package and return with a line saying one of the functions is being masked by another function in a second package, that is actually quite common. So one of the things is that some packages use the same command as others, and depending on when you install them, they will kind of mask the original version of it. So we'll see that a little bit more when we start running the library codes. I'll explain that a little bit more in a second. So now that we have the packages installed, we can look, as I mentioned, to see that they're installed in this packages area. In order to load a package or actually make it so that R knows that it can use it, you use the library command. So within the document, you should see you should see something like this. Go ahead and run the code by highlighting and clicking run, or hiding and clicking command control return to run these, and we'll see it should just kind of quickly just like shouldn't tell you much for some of them, but we'll see that for others it will tell you something. So for example, for dplyr, when I load the dplyr package, it'll say attach package. So the following objects are masked from package stats, filter, and lag, and the following objects are masked from package base, intersect, set diff, set equal, and union. So these these objects are actually commands that you would run. And basically what this is telling you is that dplyr has its own function filter, has its own function lag. and it's going to use the dplyr version of these the dplyr version of these commands instead of the package stats or package based version of that. But for this workshop, it's not going to matter. For more advanced R users, it might kind of cause some interference in the way that you're able to work. The other option, as was suggested, is to check them off under the packages tab. So I use the library command to run these. So let's say I want to also load Tibble and Lubridate. So I can go to Lubridate and I can just click that checkbox and it'll automatically load. It'll automatically like type that code for you. So this is like another easy way of loading the packages. So Tibble is the other one. And so with that, we can have all of the packages loaded. So go ahead and another good question was asked: how can you choose which function gets masked? So generally, what I do when I'm running my own code is I only load packages that I need for that particular code. That way, I will minimize the number of conflicts that I run into. You can't really choose which functions get masked because it's kind of chosen by the package itself. So Lubridate, for example, knows that it should be masking package base version of date, intersect, set, diff, and union because Lubridate kind of takes priority in terms of how it works with those commands. But as I mentioned, those aren't particularly important, like these kind of objects being masked for the purposes of this workshop.
I'm not getting ggplot2. Am I the only one?
Do you have it in your packages area?
I don't. So
maybe you could try reinstalling ggplot2. Did you run it into an error when it was installing?
I didn't think so, but I wasn't probably paying. I was.
That's okay. Just try installing that package again and seeing if it'll appear.
So the stuff that's in the packages tab, like there's a lot more than the. Yeah. But like you're saying, for this one, reinstalling it will maybe add it to the. Will maybe add it to the packages tab.
Yeah, installing the package will add it to this list of packages that are available. There are a lot of packages that are in here. A lot of them just come with R. But as I mentioned earlier, we're only going to be using the ones that I have talked about. Question of does it matter which version of R the package was built under? For this workshop, it does not. For like more advanced R usage, sometimes certain versions of R are, certain packages are optimized for certain versions of R. In this case, the packages that we are using are like very stable in that like they have like well-maintained code and that should, so we shouldn't run into any issues because of that. So here's the list of packages. I see a question. What's the difference between system library and user library? I don't actually. Oh, I see. User library and system library. System library. My understanding is that system library are kind of the main packages that like come with the base version of R. So you'll see the R base packages under there. These are some of the backbone of R packages. Those are going to be under the system library. And any added packages, any new things that you add are going to get added under the user library. All right, so if you were able to use the library command on all of the packages, and you can double check to see that all of those boxes are checked in your packages area, just throw up a thumbs up or a reaction for me to know if you are catching along, following things all right. Okay, I see some reactions. Awesome, thank y'all so much for showing this. This is really helpful. Awesome questions. Super glad that people are just like stopping me, interrupting me. Like, thank you. I appreciate that. All right, I'm gonna go. Go ahead.
Can I ask really quickly? What is the distinction between when we do the install part and when we do the library part? Is one like compiling and one?
Yeah, great question. So the install packages downloads it to your machine and kind of gets it so that the package can be easily loaded. Now that is especially useful when you're using RStudio on your desktop. You should only have to install a package one time. If you install it again, that's just updating the package. So like theoretically, you should only have to install it one time. For the library function, every time you write a new set of code, you want to load the packages that you use for your code. So you would do the library at the beginning of every session, but you would only have to install it once for each project.
Oh, so libraries for your own code, basically.
That's correct, yeah. And install is to just install it onto the machine.
Sure, got it. Thank you.
Yeah, no problem. In RStudio Cloud, you will need to install packages for every project. But if you are using it on your own machine, you only need to install the package onto your machine one time. All right, so I'm going to move on to the finding help section. There are a lot of options when it comes to finding help in R. And using all of those options is definitely something that, like, over the course of like the time when you're working with R, people would get more comfortable working with over time. The easiest way to find help is by just going to this help tab and searching for a command that you're working with. And we're going to get a chance to actually use that a few times as an example, or throughout our lesson. Unfortunately, the documentation for some packages is very, very difficult. So let's see, select. So select and dplyr is one where they have some description of what it is used for. They usually talk about certain selection features. Actually, this is an example of a better one. So it gives you like a full description of what the function does, different ways to select things, and we're going to get some experience working with these different selecting functions. These are some of the commands that you can do using that are based in this select function. The usage is the syntax, or the way that you write the code. Now, when I say sometimes the code is the usage is a little bit difficult to interpret. Seeing this is how you use the code isn't necessarily super helpful. We'll see an example of the select function pretty soon, before the end of today. Learning to unpack like what each of these arguments means does take some time. We're going to go into more detail about how commands are structured. For commands that you look up using the help package, if it's not helpful or if it's not useful, I generally tend to like Google search like the command that I'm using, what I'm trying to do. And there's almost always, for a lot of basic R questions, a forum online somewhere that shows how to use it. As I had mentioned, Another really useful tool is the RStudio cheat sheets. So this is just a link to the PDFs of some cheat sheets. If you copy and paste these links into your browser, you can open up the cheat sheets in your browser. But another way of accessing the cheat sheets is by in RStudio Cloud clicking on this cheat sheets button, and it'll take you to the list of all of those cheat sheets. The cheat sheets are a really good way of, again, looking for what the different options for commands for each library do. So under data transformation, I'm just going to really quickly show you. I'm going to copy this and create a new tab in my web browser and open it up. So this is the data transformation with dplyr cheat sheet. We can see that, so data transformation is, again, like selecting, subsetting, filtering data sets. So you can see that there's a filter command, distinct command, which allows you to remove duplicates. There's like all these different commands that you can use, and it has like a quick explanation of what the command is and an example of how the command is used. This is going to be useful for you to look at later on. We don't need to do this right now, but for those of you who are curious and want to learn a little bit more between today's session and tomorrow's session, you can look at the data transformation cheat sheet to get a little bit more familiar with it. And look at some of the command options that you can do. As I'd mentioned, RStudio has a lot of these cheat sheets. We looked at some of them earlier. You can review them later on to get a little bit more familiar with what you can do. As I'd mentioned, another useful resource is just searching them on a web browser. There are a lot of forums where people discuss code. Some of the most common ones are Stack Overflow. That is a really common one for like any just typical coding errors, like one-off coding errors. R-bloggers is another a common forum. And for those who are doing things like bioinformatics, things in life sciences, BioStars is a really useful one as well. So like when you're like searching it, for example, on Google, like how to filter certain things, you'll see that these are some of the websites that that I generally go to when I'm looking for help. The next step is that we're gonna do is to import data. But before we go into importing data, is there any questions that anyone has about finding help in R? All right. All right, so if you're down for me to move on to importing data, finally getting our hands dirty with R, throw a thumbs up, show me a reaction. What's your thoughts? Oh, seems like people are ready. Diggity dig it. Oh yeah. Wonderful. All right, appreciate your thumbs up. Appreciate everyone's attention and energy. I know things are getting started a little bit slow, but we're gonna get to it. All right, so we're now going into the importing data section. So as I've mentioned, like most command line functions, you have to import data from an external source. And there's a variety of places where you can do this. You can download data to your own machine, which is what we all did earlier at the beginning of this session. But you can also pull data directly from online sources. But before we actually import data, I want to tell everyone a little bit about the working directory. Has anyone heard this term before, or is familiar with this term before now? Or is if you've heard the term before, just drop a like yeah totally into the chat or a thumbs up. If you haven't heard the term before, okay, so this seems like it's a new term. If you haven't heard the term before, use that like expression, that shocked expression. Oh, look at that. Yeah, totally. Yeah, so when I was first learning how to do code, like I was like, working directory, like what on earth does that mean? So the working directory is just, in its simplest form, is the folder that you are currently in. So the way that R works, or like really any programming language works, is that you tell it like, where am I going to do all of my work? And so basically you have to tell it what folder to do the work in. And so in this case, in RStudio Cloud, we have kind of already set up this folder that we're working in. We can navigate to different folders. Like, let's say, for example, we want to go into this extra data folder for whatever reason. So we have some additional data. When we upload a data set, we can't just tell it like upload US COVID-19 daily, because currently R is in a different folder. So if you want to see what directory, what folder you are currently in, type in this get WD command. So get WD and with parentheses. If you highlight it and hit run or command control return, you should see something that looks like this in your console. So for me, since this is the RStudio Cloud, I see it's in quotes cloud/project. I'm gonna really quickly go into my session on my desktop, and I can type in get WD, and I show those parentheses. And since I downloaded the folder to my desktop, you can see users, my laptop, desktop, part 1. So this is the folder that I'm currently in. So if I want to go to a different folder, so I'm going back to RStudio Cloud here. If I want to go to, my neighbors are revving their engines over here. So you can set a new working directory with the set WD command, which means you type in set WD, and in parentheses you tell it whatever folder you want to go to. So but the easiest way to move around directories is to use the files area. You can, for example, if you want to move into extra data, we can click on this gear that says more, and we can set as working directory. And you can see that it runs the code for you, set WD, in quotes, cloud project extra data. So it just takes that path to the folder that you want to work in. And then to change back to the original data folder, we can go set as working directory again once we navigate to the folder that we are interested in working in here. This is really useful because basically you want to have all of the data that you want to work with in the same folder as your working directory, because otherwise you have to type in a really long path to search for that data. We'll see that an example of that in a second. If you don't have this content pulled up and you want to see the contents of your working directory, you can type in the dir command, or dir. And in the console, you'll see the list of all of the files in your working directory. So you can see that we have all of this stuff here. One useful thing is if you're trying to upload a file and it's giving you an error and you're not sure if you're in the right working directory, you can either type this command, dir, to just check to see, like, am I in the right folder? Or type in get WD, which will tell you what working directory that you're in. Right, that's really useful because we need to be in the right directory in order to import our data. Does anyone have questions about the working directory before we actually import data? All right, let's get to it. So I have a little bit of an explanation of, about what the data sets that we will be uploading. I'll talk about them as we actually upload them. There's going to be two main data sets that we're uploading. One is a data set of COVID data, so like infections, positive, negative test results, variety of other results. That's going to be one data set that we upload, and another is going to be a data set that we can download directly from an online database. There's a community called the Tidy Tuesday community, and they create basically data sets for people to get practice manipulating data and visualizing data. So it's just like a community that like thrives on like learning how to manipulate and do and work with different data sets. We're going to be downloading a data set that they collected on measles vaccination rates at schools across the country. So those are the two data sets that we're going to be working with. And then now we're going to go into importing data from a local directory. So someone asked, should I type the commands within the console or part 1R? I recommend typing them directly into the materials that I've shared with you, just because that way you can have a record of all of the codes, commands, and all the stuff that we talked about today. You can create more space again by like just hitting return and then typing into it there. That'd be the best way to kind of like make sure you keep track of everything that is written, because the console doesn't always automatically save. All right, let's do it. Let's import data. So, oops, there's an instruction here that doesn't need to be here. My bad. So the first thing that we're going to do, so let's just go straight to around line 250, where I say we're going to load our first data set. So Tidy Tuesday data sets are safe. They're curated extensively by a community. They're usually only a CSV file, so there should be no information in there besides the actual data set itself. And I'll give people like the exact link to download from that gets imported into R. There should be like no concern in terms of the safety of the Tidy Tuesday data set. So to load our first data set in R, so one of the things that like in the example that I'm bringing to everyone, we're going to be taking a look at the number of positive COVID cases per million in all the states and plus Washington, DC and Puerto Rico. And so I created a states.csv file in order to upload this data set. So the default command to read a table or read a file into R is this read.table command. And so I have the code written out for you here. And so you can just run it if you don't want to type this out, but I'm going to type it out just so that so we can kind of see an example of what R looks like when you're writing this code out. So read.table, and as soon as you open up that parentheses, it should show you like this kind of like box here that gives you an example usage. So you'll see open parentheses and it'll tell you file. So it's asking for, tell it what file it's supposed to read, whether or not that file has headings, and you could tell it what the separator is. So is it a tab separated file, a comma separated file, semicolon separated file, or whatever. These are the three main required options for read.table. And there are other options that you can add if you want. But for the most part, you only need these three main items: the file, whether or not there's headers, and what the separator is. And so you can see that the file, when I type it in, is in quotations. That just makes it so that so it's looking for a file with a string, so like a set of characters that has this specific name. So we should see states.csv, and we can close the quotations, hit comma. If we type in header, it'll ask to autocomplete. So you can, if you want to autocomplete, you can just hit the tab button. Tab will autocomplete whatever thing that you're typing in. Header equals true. We'll talk about the different character designations, what true false means and stuff in this case. We just letting it know that it is true that there are headings already built into this document. And we're going to let it know that the separator, so this is a file that is separated by commas, and we're going to want to put the comma in quotations here. I'm going to highlight that and hit run. And you should see state population, 52 observations of 25 variables. So let me know if that's something that people see and if that runs for folks. And if it doesn't, okay, got some thumbs up. Appreciate that. Cool. So that should run, no problem. There's other commands that are useful. Oh, some people got an error. So if you are, if you're getting the error no such file or directory, you're gonna want to check to make sure that there isn't a typo in here, or you're gonna want to make sure that you're in the correct working directory. So if you in your files tab see what I'm seeing here, if you click on this little gear and then click set as working directory, it'll take you to the correct folder, and then you can try again, highlight the code, and then run it. So, oh yeah, I should have explained. If you just type in the code read.table into the R script and just run it, it's going to read the table. So it's like a messy table. I did this on purpose. It's going to read the table into just directly into the console, which is not actually that useful if you want to work with it in a variety of ways. So what I did was I created an object or a variable, which I've called state pop, and I assign it using this arrow sign. So that allows me to, instead of just having R read out the content into the console, it creates an object that we can then look at in this global environment. So for the working directory, it should be the base folder in the RStudio Cloud. So wherever you uploaded the information into. If you are in RStudio Desktop, the working directory should be the part1 folder that you had open. So we can set the working directory using this gear, set as working directory. You should see that come up. This question, did you create the object on the fly? In order to work with data, you have to import them into specific objects. So it's really useful to create these various objects in order to work with the data. I'm going to talk about naming objects in a second, but it's generally helpful to like name things in a way that's like useful to you, with enough information to tell you what that object is, because when you work with a lot of different things in your global environment, you're going to see that having like a coherent name is going to be useful. In order to see the table that was created, you can type in view and in parentheses the object that you want to look at. So in this case, I already have it copied here, view state pop. You can type it out if you want. And if you hit Command Control Return or hit the run, it should open up that table in a new tab in the top left-hand corner. So we can see that there's the state name, the abbreviation of the state name, the population, and the population in millions. This is just the population divided by 1 million. giving us a decimal point. So you should see that should match up. Another way to just view tables that you've created is by going to the global environment and then just single clicking on the data name. So if you just single click it there, it should automatically run the view command, and you can see the table that you're working with there. So as I mentioned, there's a lot of strategies that can be used to assign variable or object names. Here are some best practices. So as I mentioned, it's helpful to name things in a way that's like useful, like short but descriptive and without spaces. So here's some example naming conventions. So you can so what I like to do is I like to capitalize the first letter of every word, and I just kind of string them together like this. You can go without capitalizing them, but for me, it like makes it a little bit more difficult to read. You can separate terms with points, with periods. This is an acceptable name for an object in R. Same thing with underscores you can use. But you can't use things like dashes because dashes are interpreted as like subtraction. So in this case, it would think to take the but object, subtract the not object, subtract the like object, subtract the this object, which won't make any sense to R. So you can't use dashes. You can put numbers in the names of variables, but you can't put numbers at the beginning of the names of variables because I think it interprets that as like multiplication. So this would be 4 times this object. But for now, we're going to stick with this capitalize the first letter of the object's names. Does anyone have questions about naming conventions? Are people down to move on to loading the other data sets in?
I tried retyping it, and I put a question in number 62 of the Q&A.
Got it. 1 second, I'm gonna pull up the into the window. So second, I have a lot of windows open.
Is it because
okay,
I didn't
it looks like you might be in the wrong directory. You're gonna need to move to the correct working directory. We're gonna take a break in just a little bit. I'm gonna get to the end of this reading this other data set and for everyone, and then during the break we can address some of those questions. So the other data set that we're working with is this COVID data set. So you can see I use something, a similar naming convention here. I just call it COVID data. I use this assignment command, which is this arrow. And in this case, I'm using the read.csv command. That is going to import the file that I've created called US states, or that I've downloaded US states daily, so on. We tell it header is equal to true, and the separator is this comma separated value here. So if I highlight that and then hit run or command control return, we should see another object appear in here. And we can click on that object and see more of this full data set. So I think that's the last bit before we go into importing data from an online directory. So for those who are having issues, so let's take a break until 11. And then for those of you who have questions, stick around and and I'll do my best to answer any questions that come up. But I myself need to take a quick bio break, so I'll be back in 1 minute and be able to answer any questions. So I'm going to stop sharing for a moment. I'm going to resume the recording just so that we can document all of questions. So for people who are still having issues with loading in their data set, it's probably because you aren't in the correct working directory, or the states file is not downloaded to your machine. You should be able to have it downloaded, but in your files tab, do you see? Oh wait, hold on. I'm going to share my screen. In the files tab, do you see this, what I'm circling in the bottom right hand corner? Does it look like this? Like where you have the extra data, part1.r, our project, state.csv, US states?
No, I see just kind of US.counties COVID data.
Okay, okay.
I see the bottom one.
So you are here.
Yeah.
So what you're going to want to do is you want to go to one level up, so to the project folder, if you're in RStudio Cloud, and then you're going to want to hit this gear, and then you want to click set as working directory. So that's going to set the correct directory. So now you're in the correct folder where all the other content is in. For the question about what does the states.csv mean, states.csv is just a comma separated value file that I had created and saved here that has information about the states, and so it's just a comma separated value file. You can create files like this using Excel. You can create them in text editors and so on. Go ahead.
Sorry, are comma set files just typical? Is that a definition for spreadsheets?
Yeah, it's a type of kind of spreadsheet file. Basically CSV file. There's like comma separated value files, tab separated value files. These are all ways to save kind of spreadsheet like columns. So when you import a data set, R needs to know what to assign to what column. So you'll have information separated by like a particular thing. The way that information is organized is called indexing. So a lot of people may have heard the term indexing. And basically the way that it assigns these different columns is based on, you're telling it like separated by this comma.
Okay, so then it helps it read it and process it.
Read it incorrectly, yeah.
Okay, thanks.
Do we have other questions? I'm a little bit behind in looking at the Q&A document because Leah and Jamie had to duck out for a meeting, but they'll be back in 10 minutes or so and they can catch up with some of the other questions that have come up. I'll just quickly take another look at that Q&A. So we'll get started again in like 2 minutes. I'll try to answer some questions on Q&A.
Sorry, I have a question.
Yes.
I don't know if you answered this one already, but how is a read table and read.csv is different?
That's a good question. So one of the things with R is that there's a lot of different ways to do the same thing. Read. So if we look at the help area, and we can type in read dot.table. It will take you to a data input thing. So this should load. Okay, there we go. I'm just gonna look at this, and you'll see that so these are all commands relating to data input. And you'll see that under here, you'll see the usage or explanation for read.table, read.csv, read.csv2. There's like other options as well, read.thelim, read.thelim2. Each has like slightly different functionalities depending on what they were built for. Read.table is like the original version of it. You can use any of these, but the most common ones that people use are read.csv and read.table. I'm sure there are like really nuanced differences between how each of them work, but for the purposes of this workshop and for like the purposes of like day-to-day like using these, you don't need to like, you know, absolutely know the nuanced differences between them. I in fact don't still know, for example, the main difference between like read.csv and read.thelim2. So
Yeah.
I hope that's helpful.
How do you know which, like, the separate by comma or by blank space? I don't know what's that for.
Yeah, so it depends on the file that you get. So for example, if we were to so knowing like what files you're working with is generally helpful. So if you want to take like an Excel spreadsheet and you want to import it into R, you can save the Excel spreadsheet as a comma separated value file, a CSV file, just under save as on Excel. And that way, you know, okay, I'm working with a CSV file, and then you can tell R, once you have copied that CSV file into the correct working directory, you can tell R like load this .csv file in. You can just look at the data set. If you say, for example, you're downloading somebody else's data, you don't know what the format is, I would recommend opening the data set in a text editor like Notepad on a PC or just like a basic text editor just to see what it looks like. And you'll see if there's information separated by a space, which is generally considered a tab separated file, or if it's separated by a comma.
Oh, I see that. Thank you.
Can you re-explain what header equals true means again?
Absolutely. So when we look at, let me just like explain by just taking a quick look at the data set. So if we look at COVID data, so in our comma separated value file, if we were to open that up in a text editor, you would see that in the first row, you would see date, comma, state, comma, positive, comma, negative, so on and so forth. And that is actually the name of all of the columns or the name of all the variables that you're working with. A lot of data that you'll download has that first row designating all of the names of the columns. So when you tell it header equals true, what R does is it automatically takes, it includes it as a column name or like a variable name within your data table, instead of treating it as like an observation. So you can see that the number 1 starts with this date, state, and like this information here. If you said header equals false, so I'm going to just give you an example of what happens if you tell it header is not true. So for our COVID data, we could say header equals false. And then if I run that, let's see what happens. So now I can open up the table, and you can see that it automatically creates these like erroneous variable names, v1, v2, v3, v4, v5, v6, and the column names are now assigned as observations instead of columns. So we don't want that. So we want to make sure that, and you know, you can look at your data set that you're uploading to make sure like whether or not those column names exist, because some tables do not have that. But for this workshop, things will have column names. Does that answer your question?
So it lets you basically title your columns?
Exactly. And now if I change that to header equals true and I look at the data set again, you can see it's kind of put them into this top bar without like a number next to it. All right. So let's move on to importing data from an online directory. So as I mentioned, there is a community of folks who do data visualization and experimentation for tidying up data. They call themselves the Tidy Tuesday community. If you are a Twitter user and you search the hashtag Tidy Tuesday, you will see that they release a data set every week. New data set every week, and they kind of come up with like a challenge for like how to tidy up or organize the data set and then visualize it. And people will come up with all kinds of creative visualizations. It's actually very cool. The data set that we're going to be downloading. Here's a little bit of information about the Tidy Tuesday data set. So I'm just copying and pasting that link. You don't have to do this. So a data set was put together by the Wall Street Journal, looking at 46,000 schools across a variety of US states, looking at MMR, or measles, mumps, and rubella vaccination rates for a variety of schools.
Wait, excuse me, I'm so sorry. Which working directory are we supposed to be in?
It shouldn't have changed since where we were.
I tried testing false and now I'm like out of the working directory. I'm so sorry.
So the way to fix the working directory is to go into the files section, navigate to the correct folder, and then typing in the gear or clicking the gear and setting it as your working directory. You shouldn't have, the working directory shouldn't change between different things. So
should I just be in the...
You should already be in the correct working directory.
So just the project folder? Or
Yes.
should I be clicking something within like the course materials or the
Nope.
or...
You should be in the project folder.
Okay, I'm sorry, thanks.
So the data set from the online directory is this measles data set. The Tidy Tuesday group will usually have some information about the data sources, and they will have instructions on how to get the data in various ways. They'll even tell you what the different variables mean. So this is a useful way of just getting familiar with the data set. They often kind of use what I would consider best practices in reporting and archiving data. In the case of our workshop, I've included the code using the read.csv command that we talked about earlier to upload the vaccine rate data. You'll notice that the big difference in the command that I've included here is that instead of giving it a path to the file on my RStudio like directory, or if it's on my desktop, I can just give it a URL that ends with this measles.csv. So I just pulled this directly from their website. And the read.csv command, since RStudio is hooked up to a web browser, it can access the internet and download the data set necessary. So if you highlight this and then just hit run, it might take a second to load, but it will, and you should see a new object created, which I called in this case MMR vaccine rate. You'll see that it will include something with 66,000 observations and 16 variables. And we'll talk about what these observations and variables mean in just a second.
Excuse me, before we move any further, I followed your instructions, but I'm still getting that the CSV file can't open.
For which one?
I'm still on the same problem. I just didn't want to interrupt.
Are you talking about the states file?
Yeah, for some reason, I'm so sorry. What's it called? I followed the directions. I'm in the project folder. I set it as my working directory, and I get set WD cloud project. Yeah, I don't know what to do because it's not showing up.
So I have to be in part one. I have to be in part one. So mine's set to cloud project part one with a kid.
Oh, okay. So then, okay. There we go. Thank you. Let me see if that works. Hold on.
P. Sorry.
Are you just Thank you so much for helping me. Okay.
So I think that like let's definitely take some time. If you can't get it to work right now, let's take some time to troubleshoot this after class. I do want to get through the materials for today and make sure that we can start picking apart some of the data sets. If you, regardless of the working directory that you're in, you should be able to upload this MMR vaccine rate file. So if you could just highlight this and try to run this code, you should see MMR vaccine rate get uploaded. So if just this last one works for you, throw up a thumbs up and we can start looking at how to understand and pick apart the data set. All right, I see some thumbs up. Awesome. Okay. So if you have nothing in your global environment, if you have no files within this global environment, can you throw up like a shocked expression? Okay, seems like everyone is following along. Any questions that you can answer at the end of the session? Okay, so in order to understand and look at data sets, we already experimented with this view function. We can also look at the class of data or like the type of data that we're working with. So R works with a variety of different classes of data set. If we just type in the command class around whichever one of the data sets that you have loaded, you'll see that for the most part, what we have loaded so far are data frames. So data frames are just tables, or you can think of it as sets of variables that have an equal number of observations. So yeah, it should be like basically just a table. So if we do this for any of these, we hit run, data frame, data frame. In order to look at the class of data that you're working with within your table, you're going to want to take a look at like specific columns within a particular table. And so so the main main classes of variables that I'm like restructuring this so it's a little easier to see. The main class of data that R recognizes are as follows. So there are character variables, which are just strings of like letters, alphanumeric characters that are often surrounded by quotations. So in order to tell R that you have a string of characters, you usually put it in quotations. We put the file names that we tried to import into R with quotations because it is looking for that string. There are also integers and numeric. So integers being whole number observations, and numerics will include like decimal numbers with decimals. And the last are logical. So sorry if I have typos in here. The last are logicals, which are basically true and false designations, which are really useful. So like we saw for as an example, header equals true or header equals false. That is kind of one of the types of classes of information that R can work with. So the classification of different variables is important because some operations only function when the classifications match or are of a particular type. And we'll see examples of this later on. There's ways to change classifications. We won't have to do this right now using the as.character or the as command. So this basically tells us to interpret information as a character or as an integer or as numeric or as logical. And if that becomes relevant, I can point to it a little bit later on. But let's take a look at the different classes of data that we have within our own tables. So just first type, if you have one of these data sets loaded, go ahead and try to run these lines of code. So this first one, class state pop state, we just run that, we can see that it is considered a character. And when we look at the state pop data set, we look at the state variable, we can see that it is a list of letters here. So these are just, so this is why R interprets it as a character. We could do same thing for this MMR vaccine rate for the city variable. Oh, so I'll add that the way that this command is written, or the way to look at different columns within a data frame, you can type in class, you can give it one of the object names like COVID data. I'm using the tab to autocomplete. And then if I hit this $sign, so if you tell it data frame $sign, you can see all of the different variables within the data set here. So this is a really useful way of just like browsing through what the different column names are. This is why using that header equals true is useful, because this is a really useful way of just checking to see like what the different column names are. But in this case, I can look at the COVID data $sign positive. This is the number of positive cases. In this COVID data set, if I highlight that and run it, we can see that the positive cases is reported as an integer. So it's a whole number variable, which makes sense because we can't have 1,000.1 positive cases of COVID in a state. So I'm going to take a moment to give everyone an opportunity to check the class of some other columns and type them in here. So use any of the data sets that we've loaded in the environment. Just type in class, type in whatever data set you want to work with. It should autocomplete if it is loaded, and then hit the $sign and then just browse through and look at the different classes. When you see those different classes, just type into the chat what you did and what class you got for that data set. Does anyone have questions about this particular part? So good question. What will happen if a column has both text and numbers? What class will it be? So R generally imports things that are kind of like ambiguous lists as factors. It's just a term for like a more complex type of list. There's different ways to handle that. You'll see that if we run, I think MMR vaccine rate city. Oh no, it interprets it as a character. Sometimes it'll interpret things as factors, and you have to use the as dot like character or as integer or as numeric category to change them. I hope that answers your question, Saravana. Cool. So we have a good question. Why choose to define something as a factor versus as a character? Sometimes R, when importing data, it'll automatically consider it a factor. And that can cause problems if what you are working with is actually a set of characters. Like for example, when I load some of these data into my RStudio desktop, it'll interpret this city as a factor, and I have to convert that from a factor to a character. Factors are just complex variable lists. So in my practice, like functionally, I haven't had to like assign anything as factors, but some commands will ask for a specific data type to work with. And so for example, someone just type in, they did class COVID data $sign state, and they say that it's a factor. So depending on the version of R you have, or if it's in the desktop versus the cloud, it'll interpret it in different ways. So we shouldn't run into any issues because of the data classification in this workshop, but this is just something to keep in mind when running into your code. As I mentioned at the beginning of the workshop, the most common error that people run into is from typos. And then the second most common kind of troubleshooting issue that I've run into is the data classification. Yeah, exactly. So so you default to character if it's a command that wants to work with characters. You define numeric if it's a command that wants to use numerics. So working with classes, data classes, helps R identify how to do specific functions. For example, you can't add characters together, but you can add integers and numerics together. And that's an important distinction if you're working with dates, for example, that are just lists of numbers. You don't want to add dates together. But you want to be able to add numbers together. So another way of looking at the columns that you have. So for example, we can see that these data sets have different numbers of observations and variables. In this case, the variables are just like the different types of observations that are collected. So if we look at the COVID data set, we can see that there's a variable for date, which is just a list of numbers. We have a variable for state, which is the 2-letter abbreviations for state. And then we have the number of positive cases, the number of negative cases, test results, hospitalization status, ICU status. There's a lot of really interesting data in here, data quality, a lot of really interesting things here to pick apart. But you can reach, so this is a huge table. It's really hard to see all of the different variables here. And so one of the ways that, oops, I'm trying to, here, just scroll this way. One of the ways to view all of the possible column names is by running the code call names for your data set. So if I want to run call names for the COVID data, I can run it like that. I hit Command Control Return, and it'll give me a list of all of the column names that are in my data set. So you can see that this is a pretty chunky data set. A lot of different variables, lots of observations. The observation is like, each observation for each state. We could do the same thing for the MMR vaccine rate. Look at the columns in here. We can also take a look at row names. Currently in our tables, we don't have any row names designated. And also I would caution you if you're looking at the row names for something with 11,000 or 66,000 observations, because it's going to try to read the row names for 66,000 things. And it's going to go either slowly or it won't show everything, for example. Or it won't show everything. If we want to do row names on selected, oops, do we not? 1 second, sorry. This isn't right. If we want to do row names on state pop, we could see that since no row names are designated, all we get is like a list of numbers. So another thing that I wanted to add was that for those of you who've worked with programming languages before, you could think of the different variables within a data frame as like vectors. So like just, which is essentially like a list of any of the object classes described. And so the way that R works really efficiently with vectors. So you can add columns together, multiply columns by each other. And that's a really useful way of doing like data manipulation very quickly. Does anyone have any questions about the column names, row names, or the classes of data before we go into our first step of data cleaning? This is our last section for the day, the data cleaning with dplyr. If things are looking good, you're ready to move on, throw up a thumbs up. We got a lot of thumbs up. Okay, awesome. So thanks everyone for the thumbs up. For the error that someone just reported in error row names, the selected pops variable doesn't actually exist. So if you look in your top right-hand corner, you can only pick from data in that area. That was a typo that I forgot to clean up. So I apologize for that. But if you replace that with a state pop, it'll tell you. You can absolutely change the class of data from factor to character or numeric. You do that by, if you scroll up, you can see the as.character, as integer, as numeric. So you could change any object. So let's say, for example, so I'm gonna, where am I? I'll go over vectors in just a second. So if I want to take something that is an integer, so we knew that COVID data, this $ positive cases was an integer, but we want this to be a numeric, for example. So we're gonna create I'm gonna create an object called positive numeric, just so that we can see this as an example. And then I'm going to use the assignment variable. And then I'm going to go as.numeric and then put in parentheses the column that I want to change, COVID data positive. So this is creating a new object, which is going to be a list or a vector of this COVID data positive. And if I run that, we could see positive num. We can see that it's treated as numeric. So if I look at class, positive numeric, positive numeric, and we highlight that and run it, we should see that it's treated as a numeric. So that is one way to do that. For the other folks who are getting object not found for the rows command, it's because it's a typo on the variable that's used. Use the state pop variable or one of the other variables to see what the row names. This should just give you a list of numbers since we don't have any row names designated. For the question about vectors, so in R, think of vectors as just like a list of numbers or characters or of these discrete objects. Basically, one of these data sets, so if we take a look at the COVID data set, for example, this, which is what we call a data frame, has a set of vectors which each have the column name designation associated with this. So we can think of this list of dates as a vector of dates, this list of states as a vector of states. Same thing, positive, negative results, the test results, so on and so forth. So a data frame is a series of vectors that are stitched together that are all of equal length. So another question, I haven't seen actually that before for the question of what is null in terms of for the class. Null just tells you that there's either no information there or like yeah. So maybe we could try to pick that apart later at the end of class. I haven't seen that come up before for the COVID data $ state. Does that answer the question about vectors? I know I'm kind of like glancing over it. There's a lot of things that you can learn about vectors, but essentially it's just the lists that we're working with. Okay, awesome. So let's get to this last section, data cleaning with dplyr. We loaded the dplyr tidyr packages at the beginning of the session. These packages offer a wide variety of commands to both filter, clean data frames, and do different things with your data. So we loaded them earlier so that we can start using them. Right now I have an example for the select command. So what we're doing here, and I'm going to just kind of pick apart what this command is doing. The way that the select function works is first you tell it what object to look for, state pop, for example. So state pop is a variable that we've looked at. And we want to select the columns from state pop that are listed after the data that's been given. So I want the state column, the state abbreviation column, and the population in millions column. So if we look at the state pop object really quickly, we can see that we have a state column, state abbreviations column, and these two different populations columns. We also have all these like empty columns that like don't really make any sense. And that's why we have 52 observations of 25 variables. And so if we want to just clean this up a little bit, we can use the select command. So if we highlight this and click run, what we have done here is we took the state pop variable, we selected the columns that we want, and we wrote over the state pop variable. So we overwrote the variable to give us these 52 observations of now 3 variables. And when I view this new state pop command, or this new state pop object, we can see that all of those extra variables are now gone. And we only have the columns that we asked it to pull. So that is how the select function works within dplyr. And we'll look at other examples of that later on as we do more selecting and filtering of variables. One way to check to make sure that that the commands that you are using are running is by just taking a look at the number of observations and variables here. As you filter and select different things, you will notice that you are kind of trimming down or condensing the amount of observations or variables that you're working with. So just keeping an eye on these observations and variables is a really useful way to, so if the code ran, you could just check to see if it did what you expected it to do. So does anyone have questions about the select command? Oh, I see a couple of people. I don't know why, but in my state pop table, the column is called the kind of funky character I ... state instead of state. That is, there's like an issue in certain operating systems when you load files that were created in other operating systems. It messes up the first column for whatever reason. If you stick around after class, I can show you how to correct that. Yeah, hopefully we can move forward easily from there. If it's not, yeah. So if you, I don't know if I've tried this, but so if you have the I with the 2 dots over it, ... state, this command that I have here isn't going to run. But if you copy that I ... state and replace this state here.
Yeah, so if I put the I ... state, then it does work. So it's just like
then it does work,
yeah. Weird, yeah.
Yeah, the name just needs to be corrected. Yeah, and I'll show you how to correct that name in a little bit. So good question. I didn't add a $ before state abbreviations. So what dplyr does is it, because you tell it what data frame to look at already, you don't need to tell it what columns to look for, because it already knows what data frame it's looking at. So if you didn't tell it what what data frame to look at. Well, actually, I don't think it would work, but in other cases, like if you want to create a new data frame command, so if I were to create like state pop 2, so I'm going to use a different command to do the same thing. So in this case, we use the select command. I'm going to use the data.frame command, and this is a command used to create new data frames. And all I'm going to do is I'm going to take the same columns I had listed here, and I'm going to copy and paste that in here. And you'll see that this command doesn't actually work because it doesn't know where to look. So it doesn't know what data set to look for. So in this case, we're going to have to type in state pop $state. Same thing, state pop $state abbreviation, pop $millions. So now I have to tell it what data frame to look at for each of these observations, and then it'll actually complete. So if we look at state pop 2 using which we created using the data frame command, we could see what data frame the original. So in the column names, we can see what data frame that the original list came from and what the column name was. So this is a case where two different things do a similar. Two different commands do a similar thing, but they do it slightly differently. And you'll also notice that instead of bringing in a $sign in state pop 2, it replaces that $sign with a period. So one of the reasons why I prefer to use the select command in dplyr is that it keeps the column names from becoming like confusing or difficult to work with. So yeah, we'll see more examples of the select command. All right, so now going into one more filter command. So select and filter are both going to be commands that we work with a lot, especially tomorrow as we start working on data visualization. So the filter command has similar syntax as I'd mentioned before. So the first thing that you do in filter is you tell it what data frame to look at. Oh, right, I should say that the filter command is used to pick on specific row characteristics. So the select command picks specific columns, and the filter command picks items within a specific row, which means you need to tell it what to look for in a particular row in a particular column. So the way that I do that is I tell it the data set to look at, and in our example, we're looking at the MMR vaccine rate data set in the state column. So if I want to just look at MMR vaccine rates in California, I tell it in the state column, look for what is equivalent to California. So in an MMR vaccine rate, if we look at the data set, we can see states are listed as like full text names here. And this double equals sign means to look for something that is equivalent to. So it's looking for like a series of characters. You could do this as well with numbers. And so since I'm looking for state in the data table, I'm only looking for rows that contain California within the state column. I can highlight this, run my vaccine California, or create this object, new object vaccine California, run. And we can see that as compared to the MMR, so I'm gonna adjust the windows here a little bit. If we compare the MMR vaccine rate original table with our new object that we created, vaccine California, we can see that there's an equal number of columns, equal number of variables, 16 between both of these, but there's a different number of observations. And then when we click on vaccine CA, we can see that under the state column, we only have California schools here. So it filters out all of the other states. So between the select and the filter command, these are two really robust ways of trimming down and cleaning up your data sets in very specific ways that are going to be useful for visualization moving forward. So again, keep an eye on the observations and variables as you process through data. This will help keep track of what is happening to the shape of the data. One common term that's used in like different forums is using like a wide or a long data set. If you have a lot of columns or a lot of variables, it's considered a wide data set. If you have more, like a lot more observations, it's considered a long data set. And so currently the COVID data and MMR vaccine rates, all the data sets that we're working with are already in this long format. Good question. Is it possible to use the data.frame command on rows? It is not possible to do that. Data.frame does not filter. I think there's other ways to filter based on rows, but I'm not 100% sure exactly how to do that without using dplyr. So any questions about the selector filter sections for now? If people are following along and kind of feel good with everything that we've done so far, throw up a thumbs up. Let me know. Awesome. Awesome, awesome. Thank you all so much for following along and showing me the reactions. Jinfen combining two has a question. How do we combine two columns from two different data frames into one? I would use the data.frame command to pull together columns from two different data frames into one, and then you can rename them later. If you want to test out a little bit what you've learned so far, there's a handful of questions at the end of this section that you can answer to just kind of see if you've been following along and answering and seeing that things make sense. So I'm going to say this is the end of the material that I was planning on covering for the day. I'm going to stick around until noon, or maybe a little bit afternoon, to answer any questions that have come up since then. Use this time between now and noon to answer any of the questions under this test what you learned section, or ask any other questions that you have about what we've covered today. But other than that, thanks everyone for your participation and for your engagement. There was a question, is there a way to clear the console? It is crowded with commands. There's a couple of ways to clear spaces up. So often, usually what I want to keep clear is this global environment. If there's data sets that I'm not or if there's like objects that I created that I don't want to work with anymore, like I create like test objects to test out some code, I will use the rm command. So rm is for removing, and then I just type in the object that I want to remove, state pop2, for example, which I don't want. And you'll see if you run that in the global environment, it disappears. So I'll recreate that object just so you can see this example again. So you can see in the top right-hand corner, state pop2. And then if I run rm state pop2, it removes that state pop2 command. For the console, for clearing the console, thank you, Jamie, for responding to that question. Control L. So Command L. Oops. That clears out the console.
Somebody was asking on the spreadsheet about loading data sets. That would be where you where you'd either import it or read it in. I'm not sure
Yeah.
how you cover that in the class.
Yeah, so that's in the data import section. Do you know what row that's on?
That is on 73.
73. So yeah, we loaded data sets by using the read.csv command or read.table command. So that's how we load data sets. That's also called importing data.
I think there's also a way in the interface, if I'm not sure on how to code something right, I can just do the interface and then I can save the code. There's an import. I think it's, you can, one of the drop downs like file or something, but there is an import. That was how I learned the code correctly.
Yeah, let me see. I think I've done that before as well.
I think it's the
I don't remember tools. Oh, import data set. Right, so there's a whole bunch of different ways to import data sets. You can import directly from Excel, you can import from text. Let's see. And then you can go into, so it'll take you to the whatever working directory that you're currently in, and then you can just click on like the file name.csv. That'll be one way to put it together, to open it. Comment about, I can see how many observations, variables are in my data set looking at the global environment, but is there a specific code that will pull this information for me into the console? So looking at the total number of columns, Jamie Lee, do you remember how to like list the total number of columns or rows? I think it's like length or count. I think you're muted, Jamie.
Maybe LEN.
LEN. Oh yeah, length. So if we want to look at the length, so this is the number of observations for a data set. If we do LEN COVID data, for example, and we run that. Oops. Length.
Maybe I think that's Python actually.
Length. Yeah. So length will give you the number of. Oh, that's actually the number of columns in the COVID data set. And I'm trying to remember. Off the top of my head, I can't remember what's the. So you can take a, maybe if you say like, if we type in COVID data, if we just type that in itself. So when you just type in the object name, so it's going to try to show you as much of it as possible. There's a ton of information here, so I just kind of cluttered up my whole thing. But it'll try to show you all of the different names and observations. But for a really big data set, it's not going to be able to show you everything. So at the very bottom, it'll tell you like, it'll show you like a certain number of rows. In this case, it shows us the first 18 rows. And then it'll say omitted this number of rows. So that kind of gives you a sense of how the size of the data set that you're working in. But I'm gonna look that up and have a command for everyone tomorrow.
Ibrahim, have you tried, have you all used summary yet?
Oh no, we haven't used summary.
Yeah.
So if we go summary, COVID data. Oh, this tells us a lot. Oh, this tells us for every single variable, huh?
Oh yeah, I just thought that usually there's
no,
it shows you rows and columns, but maybe it doesn't here.
Let's see, someone tried count. Boom, there we go, count. Sorry, everyone, this took a long time to find. Yes, the count will give you the number of row names. So count is the number of row names, length is the number of column names or columns.
I have questions of stuff because I got behind during the last section, and I was wondering if you could stay after 12 so I can ask questions, and also about my issue with the importing the desktop.
Sure, yeah, I'll stick around for a bit afterwards.
Okay, thanks. Sorry, this is just my first day ever like doing this.
Oh, I totally understand. It should be that way for a lot of folks.
It's hard to get, it takes a while to get used to Zoom.
I
Yeah,
cannot get
true.
this, excuse me, I cannot get this state pop command to run in any iteration. Can you do that one again?
Sure. Before we do that, can you type in get wd and
Sure.
just kind of let me know what working directory you're in? Sometimes the state pop you need to be like in the right working directory. Are you working in the cloud or are you working on your local machine?
Local.
Got it.
Let's see what happens here. I think I need to be in the data directory, right? I'm in the desktop part 1.
I think you might, yeah, I think you might need to be in the part 1 directory.
No, I'm in the part 1 directory.
Oh, then, okay, so can you type in to either the question Q&A document or just in the chat here, what the command you run, and for importing the state pop, I'll scroll up to it just so you can see it. Importing state pop should look like, this is what we did, read.table.
Hey, Ibrahim,
Oh.
if you send me a link to tomorrow's zip file, I'll have a link ready in the morning.
We're using the same materials today and tomorrow.
Oh, okay. So, okay, I'll post it again in the morning then. So it'll be the
Awesome.
same zip file. Okay.
Yeah, it'll be the same. Yeah.
I'll pop it in as soon as I get in.
Sounds good. Did that answer your question? I heard an O.
I did not run that command before I tried to ask it to select.
I see.
Is that the problem?
Yeah, so you're gonna want to make sure you run this first, and then you can run the select command, and it should work.
All right, Mr. Trick, thank you.
No, it's okay. Another issue that people were running into with the select command is that so if you look at the state pop table, you might see that the state has a funny name. So in order to fix that, sorry, it scrolls so fast. Where am I? In order to fix the name issue, you can type names and then put the state pop table, state pop here, and then that's telling it to look into the data frame. We know that we're having an issue with column 1. So this isn't particularly intuitive. I had to learn this somewhere else, and I had this kind of saved. And then in quotes, we'll just say state. So this is going to rename that first column from that I with the 2 dots on top of it, dot state, to just the state column. So you can, this isn't going to do anything for me, but for those of you who have that I double dot, give this a shot to see if that name will change. Did that work for folks? That totally works as well. So Paul just said that he used state pop equals rename, state pop, state equals, you know, he just named it in that way. And that works as well. So we have a request for looking at that last question together. So the question is, so in order to do the next step, what we're going to do is we're going to be merging two tables together. So I asked people to look at the states table and look at the COVID data table. And we need to designate a column with common values between these two tables. That way, the R knows how to merge these two tables together. We could see that state pop has 52 observations and COVID data has 11,000 observations. So how these two tables can match up is not like quite logical or makes a lot of sense. But when you tell it what column to match, it can expand the smaller data set so that it fills in with the larger data set. So when we're looking for a common variable, we're looking for something that is in common between the two. So in this case, we can see that we have state names, we have the abbreviations and population in millions for the state table, and for the COVID table, we see that there is a common or a similar column where we have the state abbreviations listed. So in that case, our state and state abbreviations column is going to be the common variable. And we'll see how that merges the two data sets tomorrow. Does that answer your question? Okay, great. R is case sensitive. It can be very temperamental. So typos include cases, any like added parentheses. Yeah, if you're running into errors, it could be that that there are some typos. So so tomorrow we're going to work on day 2.1, starting with more data wrangling with dplyr. So we're going to get to that tomorrow. Thanks, folks, for joining in. For the last bits of questions, I'm going to hang on for a little bit. I'm going to stop sharing and stop my recording now.